Hello, viewers. In today's class, we are going to discuss an important problem from Lagrange mean value theorem. Right? So here we have the problem in which we are given a function g of x, which is continuous in the interval that is minus 2 comma 1. So this is a closed interval, and the function g of x is also given to be differentiable in the open interval minus 2 comma 1, and g of minus 2 is given to be equal to 1, right? And we are also given the inequality, that is the absolute value of g prime of x is less than or equal to 3 for all values of x belonging to this interval minus 2 comma 1, which is an open interval. Then we have to prove that minus 8 is less than or equal to g of 1 less than or equal to 10. So here we'll prove this inequality using the concept of Lagrange's mean value theorem, right? So here we are given a function that is g of x, and this function is given to be continuous in the interval minus 2 comma 1, and this function is also given to be differentiable in the interval minus 2 comma 1, right? So see, when we talk of Lagrange's mean value theorem, in which we are given a function, say g of x, in some interval minus 2 comma 1, which can be taken as the interval a comma b in the usual notations, right? So if this function is continuous and differentiable, then Lagrange's mean value theorem says that there must exist some point that is c belongs to the interval minus 2 comma 1, such that the derivative of this function g of x at this point, that is c, that is g prime of c, must be equal to f of here we have the function g x, so we have g of b minus g of a divided by b minus a, right? So this is the formula given by Lagrange mean value theorem, right? So here b is 1 and a is minus 2, so we can now write g of 1 minus g of minus 2 divided by 1 minus minus 2, right? So g prime of c can be written as here we have g of 1 minus, and g of minus 2 is given as 1, right? So here we'll take 1, and this is 1 plus 2, that is 3. So now g prime of c is equal to g of 1 minus 1 over 3, right? And now we'll utilize this condition, that is mod of g prime of x is given as less than or equal to 3 in this interval, right? And here we have g prime of c, right? So we can now write here, if we replace this c by x, then we can write g of 1 minus 1 over 3. This is mod of g of 1 minus 1 over 3 less than or equal to 3, right? So what we have done here, we have replaced this c by x, right? And this x lies in the open interval minus 2 comma 1. It means x is greater than minus 2 but less than 1. So is the case with c. So c is less than greater than minus 2 and less than 1. So now we have this important inequality, right? And solving or rearranging this inequality will lead us to this conclusion, right? So what we will do here, see, we have a mod of g of 1 minus 1 over 3. So here I will make use of one standard result from the basic inequalities. That is, if we have mod of p is less than or equal to some number, say a, right? Then we can write p is greater than or equal to minus a and less than or equal to positive a, right? So this is the condition, or this is the result which can be used to solve this inequality, or to rearrange this inequality. So now if we compare this inequality with this one, then we can readily see that our P is G of 1 minus 1 over 3, and the capital A is equal to 3, right? So utilizing this inequality, now we can write negative of A is 3, so we have here 3. Then we have less than or equal to p. P is g of 1 minus 1 over 3, and this is less than or equal to, here we have positive a, so this is plus 3, right? Now multiplying throughout this inequality by this factor 3, we have here minus 9, and then we have g of 1 minus 1. Here 3 get cancelled, and here we have plus 9, right? So now adding 1 throughout this inequality will get minus 9 plus 1 less than or equal to g of 1. Here 1 get cancelled because we are adding 1 throughout this inequality, and here we have plus 9 plus 1, right? So now simplifying it, we have minus 9 plus 1 is minus 8, and here we have g of 1, and here we have 9 plus 1, 10, right? So this is the required inequality which is to be proved, right? So this is how, by making use of Lagrange mean value theorem and this important result from elementary inequalities, we can arrive at the desired result.